sorry about the fact that I'm going to speak in English, okay, because my Spanish or Castellano is a little bit too basic, so otherwise it will be too complex. And I'm also sorry that I have to ask someone to go on my presentation. So anyway, so the project is called ITAREO. The long title is about, of course, Italy and Argentina for Earth observation. So just short, it was a nice idea. And it's a combination of work by the University of Pavia, Molise, Università di Roma, and Istituto Bulic. So I'm going to start first talking about the proyecto ITAREO, and the presentation is in Spanish, so maybe it's a little bit, in the middle. Okay, next one. Of course, the work of this project, which is 3 years, it is funded by the Italian Ministry for Foreign Affairs, and unfortunately, this is not funded from the Argentinian point of view, but luckily we had still work together, the possibility to work together. It's about the use of Earth observation for the United Nations Sustainable Development Goals. And if you see this, next one, please, should work, hopefully, no. Yes. Okay. If you look at this one, this is the part that corresponds to the fact that there are a lot of indicators from the UN development goals, which are sustainable development goals that can be obtained by Earth observation. And this work is about the fact that we wanted to go together and work on the use of the satellite, both from Italy and from Argentina. So ITAREO is based on SIARGE, that was already mentioned by Danilo, so I'm not going to cover it because you already know about it. And the idea is that we use radar. Next one. So the objectives are basically the fact that we want to work together in order to develop machine learning techniques, so and data fusion technique as well, for the extraction of information in different sustainable development goals. It's a work of 3 years, so I'm not going to present everything because otherwise we'll be there through the weekend, I guess. So let's go very quickly. So the first one is the indicator Hambre-Zero. And for that, there will be a presentation later by Albise Ferrari from the University of Rome. Very quickly, what they did was basically to use Sentinel-1 and Sentinel-2 data and also COSMO-SkyMed in order to extract information about different type of crops. You will see that almost everybody will be on the area of Cordoba because, of course, it's easy to have people who help us in order to find the ground truth. Next one. So in this case, what they did was basically to work on the classification, crop classification, and compare with the classification made using Landsat 8 by INTA, Instituto Nacional de Tecnologías Agropecuarias. And they use random forest, which is, as you know, a very standard classification methodology, so no deep learning, no fancy thing, just something which is clearly, because the idea here is to find something which is working, and is working in a robust way. So you don't need a lot of points, we need something. And in other approaches that we will see, they will be completely automatic, so you don't even need point to start with. Okay, next one. So this is just a comparison, and sorry about the colors are not very clear, but you see the mappa de INTA on the left, and the mappa from ITAREO on the right. They have a very good similarity, let's say, and what you can see is also that the quality of the details is much better in ITAREO because we use Sentinel-1, and 2, which is 10 meters, as opposed to Landsat 8, which is 30 meters. So you see there is a little bit of a difference. Next one, we're talking about Agua Limpia y Saneamiento. This is a work that will be also covered in a moment by Annabella, because we have been working on radar, while Instituto Bulic has been working on Prisma data, so hyperspectral. And we are now, you know, in the future, we will try to join these two activities. For radar, next one, we have a system which automatically extracts the water surface in any place, anytime, as long as you have at least 2 or 3 images. You don't, I mean, it works also for one image, but it doesn't work so well if it's only one image. So you need at least 2 or 3 images of that area. And we checked it on very large areas, very large, let's say, water areas like Laguna Picasa, and very relatively small elements like Rio Primero, that you all know. And the idea is that SAR works independently from the fact that we have or we don't have clouds. And it is easy to find water because water is very dark, because of the fact that SAR, you know, you have the flat surface and the mirror effect. Next one. So the methodology is a little bit more complex. It's not just a classification, is completely automatic. So you don't need to have anything else than points that you know that are water because they are in old maps. And we have a lot of old maps which are not perfect, but at least that we can take in order to find some few points, okay? So those few points we use, and they are used in order to extract this methodology by a k-means classification, okay, very, very simple classification, and clustering. So clustering, and then we correct for the topography. So if you have the topography of the terrain, because we know that for radar you might have areas which are black, because they are, you know, shadow of the mountains. So we can just discard those because if you have the 3D, if you don't have, okay, you know that there are these issues. Next one. So the methodology is that we start from a series of multi-temporal data. We compute the minimum, maximum, the median, and the variance. And we do it for, and we don't do it for the whole sequence, but for different intervals. If you have 1 year, those 4 intervals are the 4 seasons. If it's 1 month, there will be the 4 weeks. Okay, you can have, you can think about many different ideas, and eventually we have 8 features, and that we use for both VV and VH. Next one. We apply a clustering effect, and then you have different classes that you see on the right that have different colors, which is the water. It's easy to see because in the water is the cluster which has the mean value, which is the lowest one, because the water is very dark. So we know that it's very dark, and therefore we use this. It's a very simple methodology. So you see, it's not, doesn't make any very fancy result, but the results are very good. So next one. And we applied it to different areas. So here for Laguna Picasa, you saw from 2018 to 2023, and looking always in the period where Laguna Picasa is much wider. So because there is a lot of water, so it's January, more or less time. And you see that there has been a big decrease in the last 5 years, 5 to 6 years. It's more or less more than 50% less wide right now than it was in the past. So it's a big, I think it's a relatively important problem. And we selected that because our friend, I mean, in Pavia, we started to work on this area, which we didn't know because it was mentioned here that it was a very important area that we wanted to analyze. But we applied it also to Rio Primero. So next one. Okay, this is again the same. So next one. So we just go on. Okay, sorry. That's just one thing, which is for people who knows very well about radar. You know that if you have an area which is water, it's black. But if you have also an area which is sand, and it's sand which is very flat, it's also black. So if you have something like you see on the middle, in the middle, which is an area where you have water when it floods, when there is big rain, the water is there. Then the water automatically reduces to only this small area in the middle. But for radar, which is on the left, you see the color is totally dark. While for optical data, you see the difference. So we change our methodology in order to use both radar and optical. And if you use only radar, you see the result is wrong, which is there. And on the right, you have radar and optical, and the result is very good. So we were able to solve a problem which we had at the beginning to find this extraction. And was a master student of mine who worked on this, and because I had this very nice idea to combine the two data. So next one. There is a let's say, no, it's not a problem, but it's a limitation. The limitation is the spatial resolution and the fact that radar is not working from the top. You know, it's not a nadir sensor, it's a slant sensor. So it doesn't work very well inside urban area. So if you try to extract Rio Primero inside Cordoba, no way. If you extract Rio Primero outside Cordoba, very well, of course. And of course, but I mean, the problem is that in Cordoba, you see very clearly when Rio Primero is coming out, while if you go outside, maybe that's the point of using satellite. You have information even where you are able to go exactly in time, okay? So, okay, but we apply it not only in Argentina, because this is a joint research, we apply this also in Italy. So we apply the same methodology in order to extract the water surface of the Po River, which you know is the biggest one in Italy, and it goes close to Pavia and close to Cremona. So I work in Pavia, but I live in Cremona, so the two towns are, and you know, Axel and Sol know very well. And we use it in order to check what was the water level in the past years, because last year we had a very big drought. So the water was very, very much smaller, okay? And here you see the extraction of the water quantity in the different intervals of time between 2020, these are the months from 1 to 12, January to December. And of course, as you know, seasons are the opposite in Italy than Argentina. So the summer is in August and July, and therefore the water is going down. But it was already down. If you look at the red in 2022, it was already down in January. Okay, so it was a big problem for the agriculture. And if you look at next slide, this is the correlation between on the x-axis you have the let's say this is and it's not written, but on the x-axis the scale is 10 to the 6th. Okay, so 10 to the 6th square meter. Okay, the water, and on the other side you have the profondità, which in Italian is the depth of the water. Okay. So there is a very clear correlation. So it means that using satellite, we can understand how large is the river, and from that, information about how much water is in the river, without actually going there and putting a buoy. We have buoy there, but of course, in only a few people, in a few places, you don't have information everywhere. Okay, and therefore, this is the other one. Okay, and now going to the other point is about the use of indicators for the number 9 and number 11. Next one. So we wanted to use Sentinel-1, COSMO-SkyMed, and SAOCOM for the extraction of peri-urban and rural areas. This will be mostly covered by next presentation by Maria Laura Carranza of the Università del Molise. So very quickly, if you just go, what we want is basically to have a series of images extracted different urban area, and then from this information we are able to find how much these things has changed in time. Okay, of course, this is not Italy, this is not Argentina. This is a part of Indonesia, so just to give you an idea, okay, because the methodology is it works everywhere. So next one. And it works on the idea that if you use SAR, urban areas are very bright. So it's the opposite of the water, so it's very bright. Again, very bright, but you need to be careful because also mountains can be very bright. isolated rock, could be very bright, you could have other things, but this methodology takes into account the fact that we are both using the amplitude and also the texture, so how it's the spatial distribution of these points. So next one. We applied it to the city of Cordoba using COSMO-SkyMed with very good accuracy, 91%, which I think is very fine. And next one, in order to obtain the expansion, so il cambio e l'espansione urbana, with COSMO-SkyMed. But also, okay, so we use the same methodology on SAOCOM data. Of course, the resolution is different because COSMO-SkyMed is few meters, and SAOCOM instead is 10 meters, as already mentioned. So the resolution is different, but the results are very good. The classification is a little bit worse, 80%, because of the spatial resolution, of course. Okay. Next one. Last part is about the work which is being performed right now. This is the last year of the project, and we are mostly focusing on this methodology, and therefore this is the only one where you will not have any result, just the idea, because it's we don't have the result. It's about vida de ecosistemas terrestres, and it's about the study of the area of the bosque nel Chaco Arido to the west of Cordoba again, and we will we are working on the Parque Provincial Chancay, sorry, and the close area, okay, which I don't know anything about forest, so don't ask me anything, but Laura is the expert. She will maybe, I don't know today, but she's working on this. Okay, so next one. So as a result, we expect to have a cartography of the wooden ecosystem for the evaluation of the natural resources in the area. So here you have the right accent, sorry. And again, comparison will be with the result by agricultural people or people from INTA. And we want to have a methodology to use radar to map and monitor this area, which is something which is a little bit challenging, but I think we have the right people working on it. Now, last thing is about the conclusion, and then I will give floor to Annabella for the second part of this presentation. The conclusions about ITAREO. I think we got enough results which are good to be, let's say, happy about what we did and about the collaboration. At the end of the year, we will have the final result also for the other things that are still missing. And for the moment, what I can say is that we have a methodology to map crop mapping, a methodology for water extension, and a methodology for the urban mapping, which are all implemented, let's say, are implemented in different things. Some of them we have the implementation in Python. Some of them we have the implementation in Google Earth Engine. If you're interested, we can share everything about everything, you know. And if you prefer Google Earth Engine, we can have it. Otherwise, we give you the Python and so on. And it's not a problem at all. And the last one will be about the use of multi-temporal data for the mapping of the forest, which is the one that is still missing. Okay, and that's it. This is just a general thing. Then you will get better representation about the different area. First by Annabella, then Maria Laura, and then Alvise, which is the last one. Thank you very much.